Okay, we're back. I told you that we would do a few more examples, so here they are. This one's a basic one. It just has a boundary of x. The derivative undoes the integral. They cancel each other out. We just plug in our x anywhere I see a t. And since the bottom boundary is a constant, I don't have to worry about it. It just basically goes to 0. And we end up with x cubed plus 5x. And that's it. Done. If your boundary is not just an x, then this one, our boundary is cosine. So we're going to go ahead and plug cosine in for t. Whoops, there's no t there. So don't have to worry about that guy. And we get 7 times cosine of x, excuse me. Plus 5. Now, we could do this individually, but the whole thing essentially has to get multiplied by the derivative of that top boundary, which is negative sine x. Okay, so in the end, we get 7 cosine of x. If I distribute this sign, you don't have to, but if you do, you would of course get negative 7 cosine x sine x. Order not important, sine before cosine or cosine before sine, minus 5 sine of x. And just in case it's a multiple choice question, that is equivalent to this. All right, a couple more. We've got 8x plus 1 as a boundary. We're going to go ahead and plug that guy in here, and we're going to plug it in here. So we have 8x plus 1 squared, squaring a binomial, plus 3 times 8x plus 1. That is the second term, sorry about that. Okay, and it's still a constant on the bottom, so I have to worry about it. What I do need to remember is that this whole thing gets multiplied by the derivative of that boundary, which is just 8. And I'm going to go ahead and kind of push pause, distribute, and do all the simplifying, and then I will distribute the 8, and you're welcome to do the same. Okay, so you see here I've simplified. I squared the binomial. Make sure you remember that that is not just 64x plus 1. It would have been 8x plus 1 times 8x plus 1, which means you FOIL. So you go ahead and FOIL this out. You get 64x squared plus 16x plus 1. You distribute this, 3. It's over here. And then I combined like terms. Hopefully I didn't mess up the arithmetic there. Then I distribute the 8 and I get to the 8. Remember, is that derivative of the boundary. 512x squared plus 320x plus 4. Okay, I'm going to go ahead and pause so I can set up the next one. Okay, here's another one. If you notice the boundaries, I have the 5x squared on the bottom and the constant on top. So what I'm going to do, just real quick, switch those, and it's just going to change the sign. So when I switch them, I put the 8 on the bottom, the 5x squared on the top, and what I'll do is I'll just put a negative here, so that allows me to switch them, but it changes the sign. So I have t squared plus 1 dt. From here, remember we are taking that derivative, so the derivative cancels the integral, and I just plug in my boundary. So I have negative square root of 5x squared plus 1. And I have to multiply by the derivative of that boundary, which is 10x. So in the end, I get 10x times the square root of 25 x to the 4th plus 1. Done. Okay, I'm going to go ahead and show another example. So we'll move this one back down here. Here we go. This one, the boundary has 4x on the top and 2x on the bottom. Again, I don't have to worry about actually doing an integral or anything. The integral and the derivative undo each other. And I get 5 times 4x squared times the derivative of the inside, which is 4, minus the bottom boundary now is 5 times 2x squared times the derivative of the inside, which is 2. And since this one only had one term, that's why when I plug in, I immediately multiply by the derivative of the inside. It works out nicely. Of course, this is going to be 16 times 5 times 4, so 20 times 16 x squared minus 10 times 4x squared. And you're going to see that this is going to give us 320 x squared minus 40x squared, and we actually end up with like terms, and you can subtract, so this will be 280 x squared. Okay, so that's about it. If you do need more help, or you're struggling with the assignment, go ahead and send me a text, send me an email, and you will find that on Canvas. So thank you so much for watching. I hope it was helpful. And as usual, you can Google this stuff and try to find other videos if you need additional help. There's stuff out there. I just create the videos to try to help you with. Sometimes it's hard to Google a video and you get about 15 of them and you don't know which ones are the best. So anyway, good luck, and I hope it worked out.